Talk about another quadratic application. In this case, we're going to talk about vertical motion. Now, this formula is actually the kinematic equation that you learn from physics, and in this case, it's -16. It's actually the acceleration in feet per second squared. When normally in physics they give you this number as -9.8. Anyway, so if you look at this formula right here, you have v naught. That's what we call normally this variable. That's initial velocity. S naught is the initial height or initial position, and then t is time. Okay, so basically, essentially, this works like this. If you plug in a t, if you plug in a time, it can tell you what height the object is at a certain point. Okay. So anyway, so now we're gonna go ahead and do this problem right here. It says you're standing on a bridge over a river holding a rock 36 feet above the water. You toss the rock up with a velocity of 20 feet per second and watch it hit the water. It says write a function which models the height of the rock over time. So we're going to come back over here and we're going to use this formula. Okay, so we have h of t is equal to -16t squared. Now because you threw the rock up in the air, that's going to be a positive velocity going up. Therefore, this is going to be plus 20t. And then finally, the initial height was going to be 36, or is 36. Excuse me. So that's the equation that I have. So that's all I have to do for A. All right. So I'm going to go ahead and move on. Remember, this is the formula that you need. All right. Now it's asking us to graph the function over a reasonable domain. Now, a reasonable domain in this instance, okay, it's going to look basically, it's almost going to look exactly what you would think, right? If you're starting here, it's going to go up, you throw it up, and it's going to go down. All right, now the reason for that shape, notice that you have a -16t squared. Remember that negative means you have a parabola that's upside down, all right? It's facing down, if you will. And the t squared means that this is going to be a quadratic, some kind of quadratic function. Okay. So now that's what it's going to look like. Now the domain, okay, notice that the domain, a reasonable domain, for example, t is your domain, your time is domain. So I cannot have negative time, so therefore I'm going to start on 0. And to figure out what this number is, okay, I'm going to have to set my equation, my height equation, in this case -16t squared plus 20t plus 36. And I'm gonna have to set that equal to 0 and then solve, right? I'm setting that equal to 0 because that, even though this is time right here, this is gonna be the height. All right, so this is the height. The y-axis is the height. So therefore, if I want to figure out when the rock hits the water, if you will, this is gonna be the point where it hits the water, right? So I need to figure that out from my domain alone. All right, so let's worry about the domain. In a minute, we can figure that out once we figure out the rest of these. Right? So when will the rock hit the water? Well, the rock is going to hit the water again at this point right here. So I need to figure out this point, okay? Because right here, notice the height is 0, right? All on this line, the height is 0. So I need to figure out this time. So I'm going to set this equal to 0. I'm going to solve. Remember, when we're doing this, it's always easier if you want to factor, all right? And when we're factoring, we're gonna try to get our greatest common factor out first. So in this case, I'm gonna factor out a -4, and I end up with 4t squared. 4t squared. All right, let me erase it. It's kind of messy. That's a 4t squared plus minus 5t minus 9. Is equal to 0. Okay, so at this point you really have a choice. If you're unable to factor this, so you can't think of the factors, what you can do is you can actually use the quadratic formula and figure out what the times are going to be. Okay, so but this one, if you notice, all right, I'm going to have to do what we call extreme factoring or bottoms up. In this case, I'm going to go ahead and use bottoms up. All right, and hopefully you saw that in the previous videos. First of all, this -4, okay, if I divide both sides by a -4, then this is really not going to matter anymore. Okay, so I still have this. Okay, so that negative 4 that I factor out is not really going to make my answer any different. So, anyway, I'm going to do bottoms up now, so I'm going to multiply this and this together. I'm going to put it over here, so I have t squared minus 5t minus 36 is equal to 0. Now I'm going to have to think of factors of negative 36 that add up to negative 5. One negative, one positive. So I have t minus 9 and t plus 4. Okay, so let's see, negative 9 plus 4 is negative 5. Negative 9 times 4 is negative 36. Great. And if you remember bottoms up, the way we do this is that we're going to go ahead and divide by my leading coefficient. In this case, that's going to be that 4 right there. So I'm going to divide this by 4. I'm going to divide this by 4. If you can, reduce. But if you can't reduce, just go ahead and bring the bottom of this up. So I have 4t minus 9. And this one is going to be t plus 1. Alright, so I have 2 times, alright, I have 2 different answers. This answer, if I set this equal to 0, if I set this equal to 0, that will give me t is equal to negative 1. This one's going to give me t, remember, I would add the 9 and divide by 4, so I have 9 over 4. Alright, now t is equal to negative 1 is not a valid answer because I cannot have negative time. Okay, so that one's out. So, in this case, I have 9 over 4. It will be the only time that I can get here. Okay, so if you put that on your calculator, 9 over 4, it's actually equal to 2.25. Right, so this is equal to 2.25, so you see the 1. So that right there, okay, is going to tell me when the rock will hit the water. So t is equal to 9 over 4. Or 2.25 seconds in this case. Okay. Now it's asking us for what is the maximum height of the rock. Right, to figure out the maximum height of the rock, remember, don't forget that if you're looking at the graph, the maximum height is going to happen right here. Okay? Now to figure that out, we can use it like the other one where we figure out the point in between, but since I don't really have that, it would be negative 1, and that's kind of a fraction, so it's kind of more difficult for me to try to figure it out that way. So what I'm going to do is I'm going to use the vertex formula. Okay, so I need to figure out when this happens. I need to figure out the time when this happens. Okay, so to figure that out, I'm going to use this formula. I'm going to actually write it down here because that's where I need it. So in this case, t is equal to negative b over 2a. Okay? And you can go back to this equation if you like, to the very original one if you like. This one, or you can go to the more factor form, which is this one. But let's just stick with this one to avoid confusion. So in this case, I have negative 20 over 2 times a negative 16. That's going to be negative 20 over negative 32. And I want to reduce that. Now that's a negative over a negative, right? If you reduce this, you get 5 over 8. Okay, so if you want to know what 5 divided by 8 is, just use the calculator. This actually would be 0.625 seconds. Okay, so that's when you reach the maximum height. So that's this point right here. 5 over 8 seconds. Okay? Now to figure out what is the maximum height, I'm actually going to plug in this right here, 5 over 8, back into this one right here. So I'm going to have to plug in this back into this equation to figure out what is the maximum height. Okay? So if I plug that in, that will be h of, let's see, I'm going to write it as 5 over 8. If you want to write it as 0.625, by all means, it really doesn't make a difference. So this is going to be negative 16, 5 over 8 squared, plus 20, 5 over 8, plus 36. Okay? So, at that point, hopefully you have one of these calculators. Or otherwise, it can be kind of messy. So we have negative 16, parentheses, alpha, y equals, and then we're going to plug all that in. So going to square that. So if you want to fast forward at this point, I would if I were you. Excuse me. That was... And then finally we got plus 36. Alright, so we got 169 over 4. 169 divided by 4 is 42.25. Okay, so that's 42.25. Alright. So remember, what that means is that 42.25, that's actually this height right here. Okay, so that point right there, that coordinate point would be 5 over 8, comma, 42.25. Alright, so remember that 42.25 is the height. So now let's go ahead and look at the domain. The domain is going to be from 0 to 9 over 4. And my range is going to be between 0, which is here, all the way to my maximum height, which is 42.25. Okay, so I know that was kind of complicated, right? So let's do one more example. Okay, so it says on this one, suppose that you just release the rock and let it fall to the water. So what that means when you just release the rock and let it fall to the water, that means that V naught is equal to 0. The initial velocity is going to be 0. Okay, if you just released it. If you just dropped it without throwing it down. So to write the equation, let me write the equation here one more time in case so you can see where I'm getting this from. So this is the equation that I had on the front of the paper. Alright, where S naught was the initial height and B naught is the initial velocity. So if this is 0, so the whole thing is going to be 0. Okay, so the whole thing is going to be 0. So my function would be h of t is equal to negative 16t squared plus 36, and 36 is my initial height. Okay, so now we're going to do the same thing. It's going to say when will the rock hit the water, what's the maximum height of the rock, and when will the rock reach its maximum height. Okay, so this is, some of this can honestly be kind of intuitive, right? But if you drop it, all right, it would look, the graph would basically look something like this. It would just be exactly half of the parabola. Okay, so again, it would be exactly half of the parabola. So when will the rock hit the water? So we're going to do these three, then we're going to come back and talk about the main range. Now remember, the ball, or in this case, the rock, excuse me, will actually hit the water at this point. All right, so at that point, that's when it's going to hit the water. So I need to figure that out. So that's actually our root. So what I'm going to do here is I'm going to set, and I'm going to write it over here. I'm going to set this equation equal to 0, and then I'm going to solve. Okay, so this one, it's actually much easier to solve for it. If I were you on this one, since I just have to solve for t squared, I'm going to subtract 36, so I have negative 16t squared is equal to negative 36, and then I'm going to divide by negative 16. So that's going to give me, if I reduce that, negative over a negative is going to make that a positive. If I reduce that, that's going to give me 9 over 4. Okay, so now all I have to do is take the square root. Now remember, when you take the square root, you're going to get plus or minus 3 over 2, but I cannot have negative times, so I'm actually just going to keep the positive side. Okay, so again, yes, you would have a plus or minus, but because we're talking about time, this is not ever going to be negative. Time cannot be negative. All right, so 3.5, it's the same thing as 1.5, okay? So that's what's going to happen. So when will the rock hit the water? Well, the rock will hit the water at t is equal to 3/2 or 1.5, right? Now it says, when is the maximum height of the rock? What is the maximum height of the rock? Now before we do that, right, to figure that out, we need to figure out when will the rock reach its maximum height. And to do that, we're going to do the vertex, all right? We're basically essentially finding the vertex of this parabola. And to do that, if you remember, in this case, normally this is x, but this is going to be t now. That would be negative b over 2a. All right, now if you look at this, b is usually whatever term has a t on it. In this case, it would be the initial velocity, but I don't have that, right, because I just dropped the rock. So therefore, this would just be 0, negative 0, over 2 times negative 16, which is just 0 over negative 32, and 0 over negative 32 is just 0, okay? So when will the rock reach its maximum height? At t is equal to 0, and I'll come back and explain this here in just a second. So all I have to do now is plug that in into my height formula to figure out what is the maximum height. So we have negative 16 times 0 squared plus 36, so this is just 36. Now let's talk about the domain. The domain is going to be between 0 and 1.5. The range is going to be between 0 and the maximum height, which in this case, that was actually 36 up here, which is what I found. Now let's make some sense of it, all right? If I'm just dropping a rock straight down, well, the maximum height happened exactly when I was holding the rock about to let it go, all right? So as soon as I let go of the rock, that was actually its maximum height. When you drop a rock, it's just going to go straight down, okay? So the maximum height was 36. And the time when that happened was at t is equal to 0, which means is right as you let go of the rock, that was its maximum. That was the time when you had the maximum height of the rock, okay? So I hope that makes sense. Now finally, this last one, okay? This one right here, it says if you threw the rock towards the water. So if you threw the rock towards the water, your function would actually be negative 16t squared minus 20t plus 36. This would be your height function, okay? Alright, so that would be your height function. And it says, when would the rock hit the water? So remember, if I'm trying to find out when the rock hits the water, what I have to do is I have to set this equation that I just found. By the way, notice that I put a negative 20, because if I'm throwing a rock down, that's going into the negative direction. So the initial velocity is going to be negative. Okay? I'm going to set that equal to 0, and I'm going to solve. Okay, now, if you have not done this before, try to see if you can figure out the answer for this. This is factorable if you want to factor it, or use the quadratic formula if you want to. If I did this correctly, which is questionable, I got that the answer was 1 and t is equal to negative 9 over 4. That's what I got, all right? So try to see if you can get there. So this is good factoring practice, all right? Remember, you have to do the extreme factoring, right? Or you can use the quadratic formula for that. But anyways, try to see if you can get there, and obviously if you get a time that is negative, well, this is not a valid answer, okay? Well, if you got some questions, I'm sure you will, then make sure to ask us tomorrow. Remember, if you encounter something where this is not factorable, then your easiest option to use will be the quadratic formula.